So this video is on RFF number 3, okay? And when we see something like this, f to the negative first, this means inverse. And that means we're gonna literally switch our x and y. So this is really y equal 2x minus 5. That's what the f of x, it's really y. And so I am going to switch my x and y. So I'm going to have x equal 2y minus 5. And then you want to solve for y. You want to get it to be y equal. So I'm going to have x plus 5 is equal to 2y. I divide both sides by 2, and I get x plus 5 over 2 equals y. You want to get it into y equal form. On number 2, when you're doing a problem like this is a quadratic. Your choices are factoring and use the zero product property, completing the square, or a quadratic formula. If it's factorable, we could factor. Now, to check if it's factorable, if we multiply these two numbers together, which is a 9, and I look at my x, which is a 7, if I can think of something that multiplies to 9 and adds to 7, it's factorable. If I can't, then it's not going to be factorable. So my next idea would be completing the square or quadratic formula. I do not like to complete the square if I have a number in front of my x squared. So I'm going to skip on completing the square. I'm going to use quadratic formula. And the formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. And so when you're doing this, your a is the number in front of your x squared, so that's going to be 3. Your b is the number in front of your x, which is 7. And your c is this number 3 here. Now, you only want to decide on your a, b, and c when this is equal to 0. So if this is not equal to 0, you need to make it equal to 0. Okay, so now I'm going to be putting those values in. So I'm going to have x is equal to negative 7, because my b is 7. Plus or minus the square root of 7 squared minus 4 times my a, which is 3, and my c, which is 3, all over 2 times my a, and again my a is 3. Okay, so now I'm just going to move this over. See if I can do that again. Get all of this. Okay, so I'm going to do this math. So I'm going to have x is equal to negative 7 plus or minus, and underneath this, I'm going to put it into my calculator. And so when I put it into my calculator, I'm going to have 7 squared minus 4 times 3 times 3. I end up with 13. So I have a 13 underneath the square root, and then on bottom I get 6. And I cannot clean that up. That's going to be my answer. On number 3, I want to write the equation of a line that has this slope, and this goes to this point. So remember, equation of a line is y equal mx plus b. My slope is negative 2/5, so I'm going to have y is equal to negative 2/5 x plus b. I'm going to be putting in this number for my x and y to find my b. So I'm going to have 4 is equal to negative 2/5 times negative 5 plus b. Now, when I'm doing this, this negative 2 over 5, when it's multiplying with this negative 5 is really over 1. So these are going to be multiplying on top. These are going to be multiplying on bottom. So when I have something on top and bottom that are the same, I can cancel those out. So really I have a negative 2 times a negative, which is going to be 2. So I'm going to get 4 is equal to 2 plus b. I'm going to minus my 2, and so I get b is equal to 2. So my equation is going to be y equal negative 2/5 x plus 2. Number 4. So on number 4, I want to find the vertex. And so to find the vertex, I can do one of two things. I can complete the square, or I can also use a little formula, negative b over 2a. I'm going to first do it by completing the square. So if I complete the square, I'm going to have y minus 18. I'm going to bring that 18 over, is equal to 2x squared minus 20x. Now to complete the square, I do not like to have a 2 in front, so I'm going to factor that out. And so I'm going to have 2 times the quantity, x squared minus 10x. And then I am going to try to complete the square. So when I do that, let me just I'm going to have a y minus 18 plus something, 2 times x squared minus 10x plus something. So to complete the square, what I do is I look at my b, which is negative 10. I take half of it, which is negative 5. And then I square that, which is going to be a 25. And that's what I'm going to be putting in here. So this is going to be a 25. That's going to make this a perfect square. 25 times 2, though, is really what's over here. So that means I'm going to put 50 on this side. And so now I have y. And here when I do my 50 minus 18, I get a 32, positive 32, is equal to 2 times x minus 5 squared. And when I subtract my 32, I get this equation. Now, when I have my equation in this form, I can identify my vertex. My vertex is going to be, because of this, 5, and because of this, negative 32. And that's your vertex. Another way to find your vertex is there is a formula for your x coordinate of your vertex. And that is that your x coordinate of vertex is equal to negative b over 2a, negative b over 2a. So if I go back to this problem and I look at my b is negative 20. So negative b means make that b opposite. So that means it's now going to be a positive 20 over 2 times my a, and my a is 2. So I get 20 over 4, which is 5. Notice I got the same number I got right there. So right now I know it's going to be 5 comma something. To figure out the something, if I know an x and I need to find the y, I take this x, this 5, and I'm going to put it in here and see what I get out. So I'm going to take 2 times 5 squared minus 20 times 5 plus 18, and I end up with a negative 32. The same thing that I got there. So both of these ways work. It just depends on which way you're going to remember on a test. Number 5. So on number 5, this is composition of function. So we're going to be starting with this f of x. We start with the inside and work our way out. So f of x, I know. F of x is equal to 2x squared. That is f of x. So now when I'm trying to find this g of f of x, my f of x is 2x squared. That's what it is. Okay, so g of f of x, what is f of x? 2x squared. So I'm going to be working this out. And so I'm going to be putting 2x squared into the function g for x. So I'm going to have 2 times 2x squared plus 3. I'm going to work that out, and I'm going to get 4x squared plus 3. And that's my answer. Again, that's called composition of functions. Okay, number 6. On number 6, we want to know where these two graphs cross. We want to do this algebraically. So this is a line, and this is a parabola. Now remember, this f of x is really a y, and this is a y. So both of these are really y equal. So I can use equal values, okay? So what I'm going to do is I am going to set these equal to each other. So I want to know where x squared minus 4x plus 7 is the same as 3x minus 5, okay? And then anytime I have a quadratic, I want everything on one side, 0 on the other. So I'm going to have x squared. I'm going to subtract 3x, so I get a negative 7x. I'm going to add 5, I get a 12. And now I'm going to solve this. This is factorable. I want to figure out what multiplies to 12 and adds to negative 7. And that is going to be a negative 3 and a negative 4. And so when I'm solving this, I'm going to get 3 over here, 3 comma something. For this one, I'm going to get 4 for my x, so 4 comma something, because these are lines and a parabola on a graph. So you want to make sure you find your x and your y. So my x is 3. This x is 4. I need to find the y's. So I'm going to be taking this 3, okay, and I'm going to be putting it into either equation. I think this equation is the easiest one to do. So when I put 3 in here, 3 times 3 is 9. 9 minus 5 is 4. So 3 comma 4 is 1 point. And then I'm going to be taking this 4. I put 4 in here. I get 3 times 4 is 12. 12 minus 5 is 7. These are my two points of intersection. On number 7, on this one, we're going to solve. So when I'm solving a square root, I want to get the square root by itself, isolated. So I'm going to add 8 to both sides. So I'm going to have the square root of 3x plus 4 equals 8. Now, once I get that isolated, I want to always check to see what sign this is. When you have a square root, a principal root, positive square root, this needs to be positive, or it can be 0 or a positive. It just cannot be negative. So this is not negative. If it happened to be negative, we're done. Our answer is no solution. But since it's not, we're going to work this out. So now I'm going to square both sides. So I'm going to square this side. I'm going to square this side. And I'm going to end up with 3x plus 4 is equal to 64. And I'm going to solve. So I get 3x equals 60. And then x is equal to 20. And that's your answer. Now on number 8, this is kind of like those, well, it's like those ones where we let u equal. So if I let u equal x squared, and x to the 4th would be u squared. U squared is equal to x to the 4th, okay? Because if I squared this, I get x to the 4th, and if I squared this, I get u squared. So I can rewrite this as u squared plus 6u plus 5 equals 0. Again, in place of my x squared, I'm writing u. In place of my x to the 4th, I'm writing u squared. Now I can factor. So I want something that multiplies to 5. This is where you got to be careful. Multiplies to 5, adds to 6. So that's going to be a 1 and a 5. So I'm going to get u is equal to -1 and u is equal to -5. And now I'm going to solve this. So remember, this equation did not have u. What does u equal? U is the same as x squared. So I'm going to write x squared equals -1 and x squared equals -5. Now, back in the day when we had to solve something like this, we did not know how to take the square root of a negative. We do know how to take the square root of a negative. It is going to be an I. So this is going to be x is equal to plus or minus I. This one here, x is going to equal plus or minus I, and then the square root of 5, because the square root of 5 is not nice. And so those are going to be my solutions. On number 9, what I'm going to do is I'm going to actually divide everything by 2. So you're allowed to multiply, divide, add, subtract any inequality. It's going to remain the same unless you have two situations. If you multiply by a negative, you're going to switch the direction of your inequality. If you divide by a negative, you're going to switch the direction of your inequality. If you do anything else, that stays. So I'm going to divide by 2. So I'm going to get x squared plus 2x minus 8. And when I divide this, that's going to be 0. So my inequality is going to stay. This is what I'm solving. Now, what I'm going to do at this point is I'm really going to find my boundary points. What makes this equal 0? So I really want to ask myself, okay, what multiplies to negative 8 and adds to 2? So this is going to be an x. And I'm going to try to find my zeros, okay? So what multiplies to negative 8 and adds to 2? So that's going to be a positive 4 and a negative 2. So I'm going to get a negative 4 and a 2. So if I'm doing this on a number line, here's negative 4, here's 2. These are going to be open circles because this is strictly greater than. There's no equal. So that means these are open. And then I'm either going to shade in between or I'm going to shade out. Now you can test a number and see where you're going to shade. So if I test a number and let's say I test 0 and I put 0 in here, into this original equation, if I put 0 in here, I'm going to get 0. If I put 0 in here, I'm going to get 0. Here I'm going to get negative 16 greater than 0. So is negative 16 greater than 0? Is that true or false? Well, that's false. So that means this is false here, which means on the outside, these have to be true. Okay, it's either going to be true inside or it's going to be true outside. So that means I'm going to be shading outside, because again, the 0, which was in between, did not make it true. And then I'm going to write my answer. X is less than negative 4 or X is greater than 2. And those are our solutions. Okay. Now, another way to think about this, and this is how I personally think about it, is I understand that this should be a parabola if I was going to graph this like on an XY axis. And these that I found would be my x-intercepts. So it'd be crossing the x-axis at negative 4 and 2. This is a open up parabola. So if I was drawing a parabola, it would be opening up like this. I meant to get a different color, hold on. So if I'm drawing a parabola, it's going to be going through like this. And what you'll notice is I want to know, where is the parabola greater than 0? Where is the parabola above the x-axis? So you see here where I shaded, my parabola is above. Over here where I shaded, my parabola is above. Here where I didn't shade, my parabola is below. So that's another way of kind of figuring out where to shade. Okay. Okay. So number 10. To find the x and y intercepts, you're going to be putting 0 in for x to find your y-intercept. So if I put 0 in for x, and what's always going to happen when it's in the standard form for this type of a parabola, this is going to disappear because when you put 0 in, it's going to become 0. This is going to disappear. So any term with an x is going to be gone, and I'm going to be left with 1. So this 1 is going to be my y-intercept. Okay, but you can also get that just by putting in 0 for x. Now to find my y-intercept, my x-intercepts, this time I'm going to put 0 in for y. So I'm going to be working out 0 equal 2x squared plus 3x plus 1. And I believe this is factorable. So let's factor it. So I'm going to have a 2x squared here and a 1 here, which means I'm trying to get a 2x squared and a 3x when I add. and that's going to be a 2x and an x. So I'm going to put a 2x and an x, and then I'm going to try to find the outside. Oops, don't want to shrink it that much. Let's get that out of the way. So when I do that, looking at this is, I'm going to have a 2x and an x. This is going to be 2x, this is going to be x. X times 1, 2x times 1. So I'm going to end up getting a 2x plus 1 times an x plus 1 equals 0. And now I'm going to solve these. So I'm going to have x is equal to a negative 1/2. And this one's going to be x is equal to negative 1. And those are my x-intercepts. On number 11, okay, we want to write the equation of a parabola with this as its vertex and then going through this point. So a general equation of a parabola in the nice form, y equal a times x minus h squared plus k. And so this is your h comma k here. So I'm going to have y is equal to a, and then since this is a 3, this is going to become an x minus 3 squared plus 5. Now to find my a, I'm going to be putting in this other point. I'm going to be putting in this negative 1, negative 2 for my x and y. So negative 2 equals a times negative 1 minus 3 squared plus 5. Negative 2 is equal to, this is going to become a negative 4 squared 16a plus 5. I'm going to get a negative 7 is equal to 16a. So negative 7 over 16 is my a. And then I'm going to write my equation. So my equation, y equal negative 7 over 16 times x minus 3 squared plus 5. That's your equation. On number 12, what we're having here is we have an Easter egg an egg tossing contest. So I'm going to start it at the origin, okay, and I'm going to have it go 40 feet away. So here I'm at 0, 0. Here I'm at 40, 0. I know the max height is 12. The max height has to be at your vertex. So your vertex has to be halfway in between the two endpoints here, okay, the two x-intercepts. So since this is 0 and 40, this is going to be 20, comma something, and the something is going to be this 12, okay? So this point up here is going to be 20, comma 12. So now they want us to write an equation. So y is equal to a times x minus 20 squared plus 12. You're going to use either 0, 0 or 40, comma 0 to find your a. 0, 0 is the easiest. So I'm going to go 0 is equal to a times 0 minus 20 squared plus 12. This is going to give me a negative 20 squared, which is going to be 400. So I'm going to get 400a plus 12 equals 0. And then when I am doing that, my a is going to equal, I'm going to be subtracting 12 and dividing by 400. Now, you can divide top and bottom by 4. And that's going to make it simplify to a negative 3 over 100. So my equation is going to be y equal negative 3 over 100 times x minus 20 squared plus 12. And that is RFF, Review for Final Exam number 3.